Hello, Dr. Case, can you hear me?
Yeah, I hear you. Can you hear me, Michael? Michael, can you hear me now? Michael, can you hear me? Michael, can you hear me? Can you hear me, Michael?
Dr. Case, I didn't hear you.
Can you hear me now?
Can you hear me?
Yeah, I hear you. Can you hear me? Can you hear me now? Michael, Michael, can you hear me?
Dr. Case, can you say something?
Can you hear me? No? Can you hear me? Can you hear me? Michael, hello? Michael, can you hear me now? All right, yeah, good.
Dr. Case, I hear you now.
You can hear me now?
Yes.
Okay, cool. All right. All right, all right. How's everybody doing tonight? Good. Good. Yeah, okay, good. What's that?
Can't complain.
Can't complain, good. All right. If you did, nobody would listen probably.
Sure.
You'd be like, all right, well, that's great. All right, anybody have any questions about anything? No? All right, so week 3, first order of business is, I haven't got an email with the groups yet, so, if you got that, send that to me tonight. If not, I'm going to make the groups up myself. Okay, so if you don't have a group, and you don't wanna, get with somebody else or get with other people, don't worry about it. But if you have a group, send it to me in the email tonight, no more than 4 people in the group, okay? But after that, whoever I don't see in the group, I'm gonna put in the group, okay? All right. All right, let me see, what else? Yeah. I think of anything administrative. Okay, no, that's it. All right, no questions, no nothing? Everybody's good? All right. All right, today we're gonna talk about process flows and analysis, right? So basically, we've been discussing, operations management on a, kind of grand scale, on a general level, just talking about, what operations management is and some of the, characteristics of operations management, how we, let's say, process stuff, is it a car's job, is it a job shop, is it, made to order, all those different things in addition to inventory and all that, right? Some of the funding and some of the capital requirements, and just a little bit about innovation and technology and about how, the CPS systems, we didn't directly talk about it in class, but it was part of your reading. And trying to figure out how do we integrate the physical aspect of business and the technological aspect of what's going on in the world, right, in order to enhance our production line operations, right? So now we're going to start getting into more detail about the actual process of, okay, how do we go about managing the production of a product, right? How do we necessarily look at, okay, what do I need as far as manpower? So in business in general, everything is a process, right? In life, right? In general, everything's a process, okay? And then all the processes, we kind of put those together and we make a system, okay? And so that system is what we use in order to go ahead and, do our business, right? We know steps 1 through 5 are necessary, all right? And we're gonna say this is the system that's gonna have certain inputs, the transformation process, and then the output or the outcome that we're looking for. Maybe we're not looking for, but whatever it is we get, okay? All right, so, when you talk about a system, you're talking about something that, the system itself is better or, more important than the parts, okay? And so that really lends itself to, you have to understand that the team is always more important than the individual within the team, okay? But you should also be looking for synergy within your team, right? When you have a synergistic team or synergistic system, that means it's really working well. All the pieces fit together and you figured out basically the secret formula to making sure this thing runs like a well-oiled machine. Be it 2 people on the line, 3 people, be it a certain type of material, be it a certain time of day, whatever the case may be. You figured out what it is, right? So you have a lot of synergy, and that's what you want within your systems, right? You want synergy within your organization in general. You want different departments working together in order to maximize the resources so we can get to the common goal, right? The common mission of the organization, all right? And so a lot of thinking when we talk about systems is applied to business because it's business, we need a methodical way in which to operate, okay? We just can't have it where we're in the same company. You're doing something one way, you're doing something the same thing a different way, right? We need to have some common ground. So we need to put systems in place that we know are proven, right? That's the most important part. They're proven, right? They work. We just need to implement them, right? Which is a mistake a lot of companies make sometimes where they have systems, but they have no proof yet of how much or how well they work, right? And so understanding that the system works as well as the people you put in charge of it, right? Or the people in it, the components in it, okay? And so understanding capacity, right? Understanding that your system is only as strong as your weakest link, all right? So you have to know that, like, okay, if I have a certain capacity, it doesn't matter if I can, if you can make 20 of something, you can make 10 of something, you can make 100 of something. I have to go with the whole system, right? So I have to go basically, we're constrained to the lowest letter number of output. Okay, and so based on that, there's my capacity, right? Until I can increase the lowest capacity, I can't really do anything else, right? I have to say this is what the system is and just recognize it and try to tweak it and make it more efficient or productive, being whatever means I can, okay? Okay, so process view. Come on in, hey, so this is a process view of business, right? Again, when you look at any business, right, there's always a process, okay? There's always some systematic way of doing things. And so here, but in order to do that, it has to go through the whole organization, right? It has touched the customer request all the way to it, right? It has to go through the organization. So it's a process, right? Operations, we had operations, and then they'll go to finance, again, informational purpose or billing or that kind of thing, and then we'll push it out, okay? And so the business itself is viewed as a process or as a system, okay? And so we look at it as a system and we say, hey, look, what is the process of how we're gonna handle our clients or handle customer requests, right? So one important part, or the most important part really about process is really flow charting, okay? Understanding how do I visually depict what the process is. In any business that you have, manufacturing, production, just any business in general, there's gonna be some kind of flow chart, right? Because people need to visually see what's going on, and that is been deemed the best way for people to understand what's going on without me wasting too much time. And so there's a specific way to go about flow charting things, right? There's different symbols and that kind of thing, right? And so when we talk about Lean Six Sigma, right? That's a kind of a processing system, right? That has, same exact symbols, right? And project managers, this is what they do, right? And all the symbols have a specific meaning to them, okay? So kind of the other names that you will see, maybe flow charting, service blueprinting, it's sometimes called mapping. It all depends, right? But they all call the same, kind of different names, but it's all the same thing. We're trying to get a visual depiction of, okay, how do we go about, showing someone how this process works without having to really go into too deep into the details that may not really be relative or pertain to anybody or be important, right? Because I don't necessarily mess with marketing. I'm all about operations, so I really don't care. I see that it came from marketing, but I'm worried about the operations aspect of it, okay? All right, so flow charting first, you really describe the current process, right? And then find ways to improve the current process, okay? So really what we're trying to do is we're trying to show people, hey, this is kind of, what my flow chart looks like. Not, these symbols are not all correct. I don't necessarily remember all of them, but arrow, the circle, and then goes to a triangle, stuff like that, right? So they look something like this, okay? It'll look something like this, where, this means something, that means something, that means something, right? This means something too, right? This means, just kind of in the flow of things, it's kind of showing you the order, right? Where it's going. And then you may have something that goes like this, and it goes to something else like that, this, and then it goes to something else like this, right? It's just showing you the flow, right? And how things go. You can also have bi-directional flow, right? It could go here and then go back up here, right? And then once it goes back up here, it can go back into here, right? So there's a couple different ways you can, chart or process flow a lot of things, okay? It all depends on how the process goes, right? It's a pretty simple system to do. Flow charting is easy, right? You just gotta notice what the symbols mean, right? And usually, I used to have them memorized. I don't have them memorized anymore. I just don't use it like that. But program managers, project managers usually know pretty well, what goes on. And also when you are a project manager, you usually don't have to do all this because guess what? It's in the Microsoft Suite application. Okay, there's a PM program in Microsoft Suite, which is basically the industry standard that does all this stuff for you, right? Has time, hacks, it has, you can add notes to it. There's a lot of things that you Gantt charts, Venn diagrams, those kind of things, right? And a Gantt chart, for those that don't know, is a PM tool that they use to kind of show actions and have time also associated with it and who's responsible and that kind of thing. Okay, so it gives you a lot of information very quickly, real easy to read, okay? So you'll see, and I'm sure everybody's seen a flow chart, right? I don't think that's anything. Yeah, everybody's seen a flow chart, okay? So for the most part, right, you're trying to, look at the flow chart, describe what's going on, but you also like to improve upon it, right? And the way that you improve upon it is by looking at the flow chart and figuring out where are my bottlenecks, okay? Where's the point of where capacity is limited, right? Based on the resource I have and what I'm trying to do, right? And how can I enhance that capacity? How can I open that capacity up so that it matches on all levels? It'd be great if all my resources match exactly the same, right? And what I mean by that is it'd be great if I came to class and everybody was here at 5:30, the class was packed, right? And everybody was ready to go, right? That's great. I could just start rolling and we could go, right? But that's not the case, right? I come in, set up my class. Sometimes I have technical difficulty. Sometimes students come in late. Others don't show, to class. They're on Zoom or whatever the case may be. Okay, so, but I can only teach or perform my duties or execute the system, the process, right? To a certain degree, because I may not necessarily have all the things that I need, right? Or the capacity may not be exactly what I want it to be. If I had to wait to start class till everybody was here, I probably would never start class on time, ever. I'd probably be like 6 o'clock, 6:30, maybe, right? Because I really don't know if someone's not here now, they probably not gonna be here, right? But do I wait? Right? No, I don't wait. I kind of work with what I have, right? So based on that, it's the same thing with your systems and your process, right? You got to figure out what your capacity and your bottleneck. And the way you do that is by flow charting, okay? So start flow chart, select a process to study, right? Get a team, all right? Once you get a team, you kind of specify the boundaries, right? What are your left and right parameters, right? What is it you can and can't do? What assumptions can you make, right? What things do you know are going to be challenges? What are some points of friction, right? You have to kind of lay all that out so everybody knows the rules that they're playing with. So as long as everyone knows the rules, then okay, we're good to go. But until everybody knows the rules, you're gonna start getting all these crazy ideas. Oh, let's just do this. Well, we have $100,000 to do whatever it is we need to do. Okay, I know that. All right. This thing here, we can't do anything about it, right? This supplier here is one of one. Okay, we need to keep the supply because the supply is very unique, and so there's no replacing this person or this organization. And so we need to kind of work around those assumptions and those conflicts. All right. Identify, sequence the operational steps, all right? Identify the performance metrics for the step. This is extremely important because you have to be able to have a way to measure whatever it is you're trying to measure, whether it be efficiency, productivity, output, outcome. How are you measuring it, right? What's your criteria for success? What's your criteria for failure? What's your criteria for break even, right? But you have to have some metric that is capturing either whether the system or the process is working or not, okay? Whatever it is that you use, be it, revenue, be it time of shipping, be it time to make the widget, whatever it is, right? You have to have something to be able to measure, okay? And then draw the flow chart and then using consistent symbols, which you're not really gonna get away from. All right, so here are the more common symbols that you'll see, right, for the most part. Start and end, okay? Process, decision, and flow. And so anytime you have any one of these things going on within your process or within your system, you use the appropriate box, okay, appropriate figure, I should direction is going in, right? But it could be anything, okay? It could be, this is where I'm sending the people, this is where I'm sending information, this is where I'm sending materials, this is where I'm sending the money, it could be anything, right? So the flow is just that, just showing direction, okay? Evaluation on if then, this is where you have people make decision points, okay? What is the customer gonna do? What are we gonna do based on whatever input or activity or task that we have got it, right? And then the start, right, or the end, again, when do we start, right? What day, right? How much time does it take in certain areas, right? In marketing, you may have a customer request for something you're making. Process and make up that time, right? And so we'll kind of talk about that later on down the line, okay? And so these are some of the more common, good morning, right? All right, so here's a quick example here, all right? All right, so this one's pretty straightforward, right? So you start here, okay? And this is all about selecting the supplier. Start here, and the buyer requests to buy, and then it goes down to see whether the information is correct, okay? And so you see here, there's a decision point, and so we use the appropriate figure, right? If the information is correct, then you continue on to the process. If it's not, you have to circle back around and start over because I need the correct information, correct data, okay? Because if I don't, then I go and I say yes, and I use the wrong data, guess what? Everything else from that point forward is not gonna work out. It's gonna be wrong, okay? And this is usually where things go wrong, okay? I asked for, chicken chicken sandwich with no pickles, okay? Is the information correct? They didn't verify. It wasn't correct, but they continued on here anyway. So when you got your, down here, you get your chicken sandwich, guess what? It has pickles on it. You go, well, I didn't want pickles. Well, when did you say that? Like, oh, okay, so they go back and they look at the receipt and they go, oh yeah, it said no pickles, right? Somewhere along the line, that information didn't get relayed to the cook, to the chef, whoever was assembling the chicken sandwich, right? And so they just put pickles on because that's the standard. That's how this sandwich is made, right? And so we have a starting point that's stable and not dynamic. It's static, right? It doesn't change. Like this is the way the chicken sandwich comes. Now, if you want to make additions or subtractions to it, you can, right? But it has to be annotated properly. All right, so let's just say we go to yes, all right, buyer identifies supplier. We call the supplier, okay? Now the supplier has a decision point, okay? Can we do this or not? All right? Supplier says no, we can't do it. Guess what? We go back up here, find another supplier, okay? Supplier says yes, we can. Okay, cool. We pick that supplier, right? Now, the supplier may say yes, they can, but in some instances, they really can't. Okay? They're saying it because they want the business. And they're like, hey, we will figure it out later. Let's just get this contract, let's get it locked in, and then we'll figure out what we need to do. Even if we need to subcontract or explore the options where we don't necessarily make it ourselves, right? But we'll pay someone or pay another company 50% of the proceeds, right, to do the work. Okay, so we basically get paid 50% to do nothing, right? Except find a supplier. Right, so if the supplier's capable, select the supplier, boom, and then that's the end of that. Okay, and then so this is basically their process, right? Their system, sort of, for how to select a supplier, right? So it works the same way for everything else. Okay, now depending on the industry, some flow charts are going to look way more complicated than this. All right, I think like for the most part, I don't, not the most complicated. One of the more complicated ones I've seen is ones at hospitals. They're kind of crazy. The flow charts at hospitals and really big companies, right? They're nuts. They're all over the place. I've worked on flow charts that are like the size of the wall. They can get very cumbersome and confusing at times, right? To understand exactly where everything's going, what every decision point is, right? Especially if you're an operations manager. You just can't decide I'm just gonna pick on one spot and say, okay, this is where I'm focused on. You have to understand the whole thing, as any senior executive is gonna need to do, okay? Now, you may just need to know your part, right? If you're just a specific person in a specific department, but at the end of the day, it's always beneficial to know the whole thing, right? To see what's going on. You may not understand everything that's going on, but at least you know, okay, well, I know it has to stop here, I know it has to go here, I know it has to go here, right? And these are all opportunities in which we can make the system more efficient, okay? There's always another supply out there that's a little bit cheaper, right? That's also providing the same amount of quality. There's always another, skilled hand that I can hire that's better, right? There's always some way to reduce costs, right? It just depends on whether or not I'm willing to sacrifice that particular thing to get to that efficiency or productivity level, right? Many times it's just a matter of, okay, instilling the organizational culture, right? So that people understand, like, hey, I need you to work hard, not burn yourself out, but I need you to work hard and to be focused on what we're doing here, right? And for most folks, it's not really a big deal, for the most part, right? Service blueprint. All right. So here's a simple flow process chart, okay? So again, operation here, okay? So a little different from what we had earlier, right? So this operation, this inspection, this is transit storage and delay, right? These are more functions of what's going on, right? Before we were kind of just getting like, okay, direction, start and stop, that kind of thing, right? Here we're actually saying, okay, what phase is it in? Okay, if we have a product or something or service, what phase are we in? Okay, and who does it belong to, sort of? And that's really what it's telling you here, right? So operation is the circle, inspection is the square, of course, the arrows, transportation, flow again, movement, right? Triangle storage and D is delay. And you can remember that by it looks like a D. So delay, all right? And so we put all those things together, and here's an example of a flow sheet, okay? And so they don't really use these anymore, okay, not in this manner, all right? I don't know what each company uses now, they're kind of different, depending if they're using technology. If they're using Microsoft Office, the PM manager, it looks kind of like this, but not exactly. Has a few more boxes and that kind of thing in it. But has anybody ever used one of these before? Something that effect? No? Okay, so not something you're gonna necessarily see outside of manufacturing and production, I think. You never use one of these before? No? Okay. Does your company at all?
No.
You guys don't have a flow, but not this time, but you guys have flow charts and all. Yeah, okay. All right, so it's pretty easy to understand, easy to follow, okay? So if you start at the beginning, right, and you just kind of see what's going on, it tells you operation, it tells you who, kind of commissioned it, right? Chart number, the date, all the kind of demographic or, information you need, right? All right, and then it has a summary up here of all the operations, functions, delays, storage, and whatnot, okay? And then it tells you whether this is something that's going on right now or something that's coming up later on down the line, right? But then this is in feet. Okay, so this know, right? delays in storage, okay? So here is the option movement, all right? Okay, so this operation movement, all right, then we see that it's moving from, wherever it's at, into transportation to the warehouse, right? 90 feet, okay? This whole thing from here to here takes 60 minutes, all right? And then we're going to, delays, right? And delays is on distribution desk, all right? And this is something that you have to factor in, because things get to people's desk, they may not be there, they got other priorities, right? Or it may just sit there because they just don't feel like messing with it, right? Whatever the case may be, or they're waiting on something, right? But we know there's a delay there, right? And then boom, comes back. We go back to operations separated according to work areas, all right? And then we go down here, that's 30 feet, right? From wherever this is coming from to wherever this is going, all right? And then time 10 minutes, and then taking the start points, wait for order, so forth and so on, right? But you can see it traces it pretty well for you, right? So it kind of creates this kind of flow chart for you that you can just take and just put on paper. Here you go, you just cut and paste, and just boom, put it on like, okay, this is the flow chart for this particular process, right? So you can see it pretty well, right? Or produce, dairy, meat departments, right? And so picking, I don't know what picking means exactly, I guess picking the meat, I guess. That's what it looks like. So basically, it looks like a meat operation where they have a slaughterhouse, probably a storage, for all the meats that they cut, and they are going to go ahead and try to distribute the meat out to whatever, vendors, whoever's trying to buy it, okay? So total time, 526 minutes, all right? So that's what, about six, what, seven, no, I'm talking about 60 minutes, nine, about eight, no, nine, about 9 hours? Yeah, about 9 hours, right? No, not 9 hours. Yeah, I'm right, yeah. 526, yeah, about 9 hours, right? Yeah, give or take, little less, but between 8 and 9 hours, okay? So this whole process takes the day, okay? So this is basically a daily thing, all right, that they're doing here, right? Okay. All right, so when it comes down to, when you're doing going through the whole process, right, and trying to understand, okay, the analysis piece, right, you look at the flow, right, is it balanced, right? Are there any hiccups along the way, right? Where do I see the most time spent in a particular place, right, or particular activity, right? Does it, go to a place that is not necessary or redundant in nature, right? Time, how long does it take to produce one unit, okay? And then once I figure that out, right, where does it spend the most time? Where does it spend the least amount of time? Is there a way for us to cut that time in some kind of way where it's more effective and more efficient, right? Quantity, right? How much are we producing, right? Quality. So this is important because we want to make sure that the product we're putting out is of the highest quality. So, and so, because of that, we're trying to figure out, okay, historically speaking, right, what is the defect rate based on how quickly we go, what it is that we're making or doing, right? We're trying to figure all that out. Sometimes you'll have where the speed of the process itself will, somewhat sacrifice quality, right? For speed, right? And we don't necessarily want that. We want to get to the point where we can make a quality product in a certain amount of time, and that's what it takes. That's fine, you know, but we don't want to rush the product for the sake of making it, only to find out the product is not up to par, okay? Because guess what? We're gonna waste time, we're gonna go back again and start all over again to do it right, okay? So we don't wanna do that. If the process takes 10 minutes, that's how long it takes, right? So we don't wanna, you know, rush it any more than we need to because we're looking for a certain outcome. If we don't care about the outcome or the quality of the product, and we're just kind of just looking to do something or make something, then that's fine. We don't need to worry about that. But I don't know any business that's not worried about quality. Okay, you have to worry about the quality of the workmanship and whatever it is you're providing. Okay, and the cost, of course, right? That's the whole point. Right? How much does it cost? Where am I spending excess cost? Where am I, you know, losing money? Where am I making money? Where am I maximizing the folks, right? The resources and that kind of thing, right? So I want to make sure that I can, you know, in some shape, form, or fashion, reduce some of these extraneous costs, okay? And limit waste, fraud, and abuse the best I can. All right. So when you're talking about measuring this process flow, right? The system capacity that I was talking about earlier, right? The capacity of the most constraining resource, okay? That's considered the bottleneck, all right? The point at which you have the lowest output, right, for that particular resource is the capacity or the max that your system can really push out, right? Because you really can't exceed the lowest, you know, variable, lowest factor. So again, your system, your process only is strong as your weakest link, right? The weakest process. Right. When we look at the flow rate is you know, the minimum flow rate, right, is a function of supply, demand, and capacity. Okay? And the throughput time when the processing begins until the product or service is completed, right? So from beginning to end, right? From the process itself, not from when you know, let's say the customer gets it. Well, the customer input, that's kind of where it starts. But once the customer puts in whatever it is, you know, till the customer gets it, how long is that process, or till we're done with whatever it is we're done, and then we kind of leave it in the hand of shipping, right? Because we really can't control shipping once it leaves, you know, our chain of custody, okay? And so we look at the throughput time, the flow rate, system capacity, super important aspects of the whole thing, okay? So we look at Little's law, right, which is measuring process flows, okay? Average number of things in the system. So basically, how many widgets, gadgets, or whatever are we producing or would we like to produce, okay? Average throughput time. What's the average time that it takes to get from the beginning to the end, okay? And then average flow rate into the process, okay? And so basically, this is trying to just make sure that the most ideal situation, right? That's why it's in a steady state, right? Assumes everything is good to go, nothing's wrong, everything is running like it's supposed to, and this is what we know the machine does or the people do, right? And we use those laws to measure process flow. All right, so little law example, people are in line to get through security checks at music festival, an average of 10 people per minute are processed. People spend 24 minutes in line on average. What is the average number of people in line? Okay, so we just go to Little's law, right? Number of things in line, throughput, okay, flow rate, okay? So we have basically 24 minutes in line. We have 10 people, right? No, 10, yeah, no, average 10 people per minute, excuse me, okay? So 24 minutes times 10, they give you 20 to 40 people in line, okay, on average, all right? Same problem, but an average of 4 people, right? So what's happening between here and here? Between the two examples, what's the difference here? Hmm? Okay, yeah.
They're just changing the equation.
Yeah, so basically, this line is slower.
Yeah.
Okay, that's all it is.
Time difference.
Yeah, there's a time, this is pushing out 10 people per minute. This is only pushing out 4 people per minute. All right? So, in what scenario would you think this would be like interesting or critical? What scenario have you been in that this applies? Any personal scenarios that you can think of that this would be like, oh, okay, kind of see where that I've been in that situation before.
Catch a plane,
Yeah, what is?
Where?
to catch a plane.
Okay, catch a plane. Okay, all right. What, the same thing? Okay.
Maybe like a concert.
Concert, yeah, concert like the example, right?
Yeah, Christmas time at airport.
Yeah, that's terrible. Yeah, depending on the person, right? I always counted this one at the supermarket, on the grocery shopping. You have 5 lanes, right? And you're trying to figure out which one's gonna go the fastest. Huh?
Maybe sport game like a stadium.
Yes, they do too. Yeah, which line is the fastest, right? I'm gonna get my beer. Which line's gonna get me the fastest back to my seat, right? So I can avoid the crowd. I can go to the bathroom and get back to my seat before I get stampeded, right? And so you can tell this person is moving a mile a minute, right? This person is more moving like a minute a mile, all right? Really, really slow or a little bit slower, right? But again, these 2 lines, there may be different things going on, right? This time may be a beer line where I'm just pouring, right? This may be some kind of hot dog line or some kind of food line where, you know, people are taking the time to kind of order like, well, you know, I kind of want the burger, but I want the chicken sandwich too. And can you do it with no pickles? Can I get it medium well? You know, so it slows everything down, okay? You have to understand that. So it's important to know what, you know, the throughput is, right? And how much the average time of the flow rate is and all that stuff, because you can tell people, right? Hey, you go to this line or go to that line, right? Or it's gonna take you 10, 15 minutes to do this, or 10, 15 minutes to do that, or 5 minutes to do that, right? So they can plan accordingly. Well, I'm gonna go ahead and I'm gonna stand the food line first. It's gonna take a little bit longer, and then I'll go to the beer line. Or I go to the beer line, get my beer, and I'll drink my beer while I'm waiting for my food, right? Because that's gonna take 10 minutes, and I'll be back in 30 minutes or so, okay? So all this stuff is important to understand and know, right? So here's an example, right? Pizza USA example, and you can tell activity, number of time, right? And who or what is involved, okay? So, the activity, take the order, 1 minute, who's doing that? The assistant, whoever that may be, okay? Make the crust, 3 minutes. The chef's doing that, the chef's doing the preparing the adding ingredients, okay? The oven is doing the bake time, and you notice the oven is 24 minutes, okay, to bake. All right, that's what it's doing, okay? Cut the pizza and box the order and take the payment, all right, assistant. Now, you can see that the longest amount of time we have is the oven, right? The cooking process, right? Which makes sense, okay? Because everything else is pretty easy, everything's already set up, it's done the right way. We just basically boom, 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 dough's already made, they'll pull it out. You know, everybody's seen Domino's and Pizza Hut and all those guys that make pizza, okay? All right. 2 more toppings added to every pizza, 2 employees working at a time. Oven can bake up to 4 pizzas at a time, okay? And so, if you see the 2 employees, right, the chef and assistant, and then you got 1 piece of equipment, the oven, okay? So now, oven can bake up to 4 pizzas at a time, right? So, there's some room for adjustment here, but we gotta figure out where, okay? What can we get away with? Can we alter the cooking time by maybe upping the temperature in the oven? Maybe, right? Can we lower the cooking time, right? By increasing the temperature in the oven? Maybe not, depends on what the recipe calls for, right? Sometimes, you know, for most pizzas, I think if it's brick oven, it's like 800 degrees or something like crazy like that, right? And so that's not something I can necessarily, you know, pull back from, increase or change, because it's necessary for it to come out a certain way, okay? McDonald's fries, it's French fries at a certain temperature because it comes out a certain way. So I can't really fix that, right? I can't change that too much. So what I can change, right? Maybe the assistant, maybe the chef, maybe I can automate a lot of this stuff, okay? I don't know, right? And it make it easier for them to take payment, take the order, all that stuff, or maybe the order just comes in automatically, right? On a station, right? Everybody familiar with POS systems, right? POS systems, whenever you go to, well, most times, when you go to a restaurant, all right, and you order something with the waitress or waiter, they go to the little station and all they
Put the
do is
case?
punch it in. Yes,
Oh, you're not sharing your screen?
did it die out? Okay. Hold up. The Zoom, the internet just is not strong here, so keeps fading out on me. Hold up. Un momento, por favor. That better?
Good.
Yes.
All right, thank you. All right. So. So, all right. So, all right, so we got the whole pizza thing down, okay? All right, so this is just a very basic flow chart of the pizza process, okay? So, start, of course, take the order, make the crust, add prep, right, and see the appropriate boxes, right? Well, not really, sort of, right? But make the crust, prep, add, bake, cut, take payment in, right? Very simple process, right? When you're just looking at it visually, for someone who wants to understand what goes on in the pizza making process, right? It comes in, once I get it, I get the order, I start making the pizza, okay? The person making the pizza normally is detached from this whole process, sort of, right? But
Actually, I have a question, like,
Yeah.
in this, like, machine, we are seeing that, like, the take an order and take payments are different steps.
mhm.
But I think, like, most of they are doing it at the same time.
Yes, it's, even though they're doing it at the same time, it's still considered separate, right? Because you can't have it where you can delineate those two things, right? So let's just say you're at a restaurant, I take the order, but I don't pay till the end, right? Even if at a pizza place, like if you go to a sit-down pizza place, right? You don't pay right away, right? You pay at the end. But you're right, it can be done at the same time. And usually, if you go pick up Domino's or something like that, yeah, they'll do it right there. Like, they'll take your order and then boom, you pay us, right? Or if you do it online even, boom, you pay us, right? And so it can be done. This video is showing it as separate, right? But if that could be a place where we, kind of cut some time, right? We say, look, take the order and take payment at the same time, so that when the pizza's done, boom, right? Because we don't need to wait, they don't need to wait for take payment or, they have to wait to take the order, but not the payment to start taking, making the pizza, right? So we can take the order, send that order in the meantime, we're wasting time. Let's take the payment also, right? And so that we have everything figured out, we're done, it's closed, the only thing we wait for is the product, okay? The issue at hand is that sometimes, once you close out this particular transaction, if there's an error, now you gotta go back, right? So now I have to kind of open this transaction back up, because the customer maybe says, oh, you know what? I didn't want this on the pizza, I wanted that. Or I wanna add something to my order, right? You have to open the order back up. That's why a lot of places don't necessarily close out the order, when they take the order, they don't take payment, right? Because they're expecting you to do modifications, right? So instead of closing it out and then maybe archiving, right, we leave it open till everything is done, right? Because there may be issues where the person, whoever's at the register, made a mistake, right? And now they need to go back. But going back may be very tedious, maybe a pain in the butt, right? It may require me to start a whole new order over again, or I may not have access to it, right? If you go to any grocery store, really, any store, whenever you have to void something out, and you go to the cashier, and they're checking you out, and you say, how much is that? You go, it's $20, I don't want any more, all right? But they've already rang it up. Oh, okay, wait a minute. Customer service, needed at cashier 5, somebody comes with a little, manager comes with a little thing or code, punch in the code, so you can keep going on, right? If not, the process stops, okay? Sometimes it stops until the person gets there. Sometimes they can continue on, but they can't close out till that particular task or that activity is closed out. All right, so say you have a coupon or something like that, which happens a lot. People have coupons that have vouchers or something like that, and they don't tell the cashier. And then the cashier rings everything up, and then it's like, oh, I got coupons. Okay, cool, let me see the coupon. Or I read a discount or whatever the case may be. Right? So good question though, and it's popular. Again, this is just a basic flow chart, not, hard and fast. Oops. All right, so again, has all the time going in, you can see what the total process takes, right? And not too long, except for the pizza baking, okay? All right, so throughput time, right? 1 + 3 + 2 + 2 = 24, 32 minutes, right? So basically, from the time that the person put the request into the time that they get the pizza and they walk out the door is 32 minutes, so a half hour. So that's not too bad. If you're sitting there, you're waiting, it's not too bad. The other thing that, when you look at this and you look at the process, right? And you see there's some downtime, right? What do you do with that downtime? What do you think about as an entrepreneur or the person that owns the organization? What does that person do with the downtime? The client, the customer, what do they do with that downtime? Prepare? Prepare for what?
More pizzas, like 3 cars.
If you go to, pay attention, next time you go to a bar or something, you sit down and you order your food, and you get your food, and you're just sitting there waiting, what did they ask you?
What do you want to drink?
Would you like a drink, right? Would you like something to drink while you wait? That's the key, would you like something to drink while you wait? In most, 9 times out of 10, you're gonna be like, yeah, okay, cool, all right, I'll have a drink, all right? Sometimes they give you water, right? Other times you're going for something a little more adult, okay? And so they're like, hey, we're gonna get a pizza out of you and a drink, okay? And so that creates different streams of revenue. Right? Or you may go across the street and go buy whatever the ball, go to work. We can Okay, so we looked at the bottleneck already. So we looked at the bottleneck already, okay? And see that, so the other source activity, all right? So good, not more than 10 pieces per hour, and that's the bottleneck, and that's our capacity throughput, okay? All right, that's it. So in that case, right, as we look at our process and we figure out, the throughput, the bottlenecks and all that stuff, right? And we come to the conclusion that, you know what, we need to do better, right? Because Domino's down the street, they're punching out 14 pizzas an hour. Why is it that we're only doing 10? It's not like anything is different in pizza making, right? Are the ovens better, or the people are better, or what ingredients are they using, right? Are they using pre-cooked stuff, right? Is our stuff justified in the time, in the sense that we use fresh ingredients, right? Kind of like going
Yes.
to. Yeah, I know it's not presenting. It's shut down again. I'm gonna hook you back up in a minute.
Okay, thanks.
Um, like when like when you go to Chipotle or something, right? It's a pretty quick process, but everything is basically fresh, made that day, all right? But sometimes you go to McDonald's or Burger King or some other fast food, it takes forever in a day. Even though those things are pre-made for the most part, right? So again, different things, different components within that system and the communication piece within the process, right? If everybody's talking, and how is the communication facilitated, right? If it's just word of mouth, then things are gonna fall through the crack. If it's relying on me telling you, hey, flip the burger, hey, drop the fries, you're gonna have some issues. But if it's automated, right, then I know, okay, boom, the order's in, what takes the longest to cook, right? And that's kind of where we start, right? If you're cooking, if anybody here is a cook or chef, you always know when you're cooking, you start with the thing that takes the longest, all right? And then if you happen to be cooking something with shrimp typically goes last because it cooks fast, all right? 2, 3 minutes, your shrimp is done, okay? So you're not gonna do that with chicken. Chicken, you're gonna put in, relatively early into the recipe, get that going, all right? Because you know that's gonna take a long time as compared to shrimp or some other, or even steak, where there's different degrees of, doneness, all right? Where people want it medium or whatever the case may be, okay? But you can go in, you can re-engineer, redesign your process, okay? And it happens all the time. You hear it all the time. Re-engineering the process, reverse re-engineering, redesign, okay? And all that means is that we're gonna look at the process and try to figure out how can we enhance it? How can we make it better, right? How can we improve it? By looking at the bottlenecks, by looking at the capacity, by looking at the throughput for every resource that we're using, right? And figuring out where exactly is everything kind of sitting or not sitting, right? Does it need to be here longer? Is there a way for us to, do, simultaneous activities, all right? And then kind of cut the process down, right? Or get to a flat, here, the companies talking about that they're flat, right? Like being very vertical, okay? A lot of hierarchy, right? The government is a lot of red tape, right? All that means that there's so many different levels that it takes a long time for things to go through, right? But if you have a flat organization where just one or two people make a decision between me and CEO, things go faster, okay? And so how flat can we get it, right? And still maintain our quality and our efficiency and keep the cost where we need it to be, right? That's the most important part. All right, let's take a quick 10 minutes, come back, and then we'll forge ahead. Mike, I'm gonna fix this real quick. You good, Leila?
and cancellations, it's gotta be an overbooking deal. They gotta be like, can't, like, scheduling 50 people on these providers.
Yeah, and this is a perfect example of throughput, right? Capacity, like you have one poor doctor there, that person can only do so much in a day, right? You can't expect them to take two schedules or
It cuts
two,
down on quality.
Yeah.
In an area where quality can't be.
right, can't be compromised, right? Yeah,
Mhm.
you can't compromise the quality, that's kind of the important part
Because
of it,
organizations can't make money if they don't.
right? But, hey, can you close the door, please? Please close the door.
I mean,
Yeah.
they did it, but I don't.
Yeah.
And but now they're losing personnel because of burnout.
Yeah.
They're like, oh, it's COVID.
No, no,
The bottom dollar that
Yeah.
you guys keep running for.
yeah, you guys kind of,
Fed resources are completely don't work as fast, are, you know, and you do more with less.
Yeah.
In reality,
yeah,
like, we can't process stuff fast enough because our computers,
don't, yeah,
they stall or they freeze or they, you know, just sitting there trying
Yeah.
to type notes. And
too much data on them, not a processing power.
I mean, they're not gonna update them, because that's more money.
No, yeah, you know, that's once every 10 years.
Then I think actually are new because they just built that clinic.
Really?
Well, Kearney's only 2 years old.
Oh, that's right,
And
yeah,
ours are already stalling.
yeah,
I don't know, it's, it comes down to money,
yeah, they're not spending
a lot of dollars, you know.
any. Nope, not at all. All right, so process redesign, right? So basically, we look at a particular system or process, and we try to want to build efficiency with it or improve it somehow, okay? And so, the first step, like any other problem, right, you gotta analyze the problem, identify what it is that you really, think is the problem or the issue at hand, okay? Then you kind of put in your business engineering, right? And so every company has some function within operations that go in and re-engineer stuff, okay? That look at, you know, the design of the process and try to figure out, is it the person, is it the equipment, or is it the resources, right? Outside of those two things, right? Is it not enough money, okay? Or is it some kind of regulation, some external factor that we have no control over? Where can we improve or enhance the process, right? But we first have to identify what that is, right? So when you try to do a redesign, you want to organize around the outcome, not the task, okay? So what is it we're looking for at the end of the day, right? So if we're looking for a better product, a better service, right? We say, okay, this is where it is, this is where we want it to be, right? And then you kind of break it down from there, right? Have people do the work, process their own information, right? There's nothing better than firsthand information and getting it from the source, okay? You as the CEO or the operations manager, you're not actually on the production line. So you really don't have a sense of really what's going on with that particular process right then and there. The guy or gal who's taking the screw, who's actually putting it in, right? You don't really understand the nuance of their job, right? It may be mundane, it may be tedious, it may be, you know, very inconsequential in the whole scheme of things, but that one little bolt, that one little thing, right? Could have been that bolt that was missing off of that plane when the door flew off, right? On that airline, that Alaska, I think it was Alaska or one of these airlines, couple months ago, right? When the door blew off, right, midair, they come to find out that there's a bolt missing. Okay, so now if you look at Boeing's in all kind of trouble, okay, all kind of deep water, right? They're not a problem, and so they've gone back to their supplier and kind of find out the supplier they're having issues, right, with their quality control, right, their personnel.
The bolt supplier.
Yeah, so basically Boeing, they don't like most companies, they don't make any of the stuff there, right? Everything gets shipped there and they assemble everything there.
Right.
So the people that made that particular door, right, that component, it's because I think it's like a couple pieces, they forgot the bolt. And so that's why the door blew off, because there was nothing there to keep it intact. What they can't figure out is who did that work, right?
Now, would it be an assembly deal where they didn't bolt the door down?
Say that again?
It wouldn't be an assembly deal where they.
It
didn't
would, but
bolt
they're looking
door
for the
down?
specific person. They're looking for the specific, because with that kind of stuff, everything is signed off on, right? Especially in aircraft vehicles, you kind of sign off on your work, like
Right.
this was done, this was done, this is a checklist, boom, boom, boom. Especially if you're dealing with physical component part, it's all signed off on. For some reason, they can't find who signed off or who didn't sign off or who was assigned to that particular task for that door, right? And so I think they don't want to say, because if they say, they already know that person's pretty much done, right? So I think they're trying to protect them, or either it's something, with the suppliers, it's like, we're just not gonna give up our folks, or whatever the case may be, right? And so now Boeing is looking at, okay, they get a new supplier, right? Which is not easy, because that supplier they have is really one of two, one of three, right? Because we're not dealing just on a regional level, we're dealing on a global level, right? Of people that are, there's only so many airplane manufacturers in the world, right? And Boeing is one of the biggest one, if not the biggest one, right? And so Southwest Airlines is suffering, right? A lot of these airlines are suffering because they had orders in for Southwest, for instance, was supposed to buy 73 new 737s or something like that, right? Boeing came back and said, look, we're kind of going through this stuff. We got to cut your order in half to 40 something. Of course, Southwest wasn't happy about it, but it is what it is, right? What does that mean for Southwest? Now we got to go back and we got to redesign all our line, all our routes, because we don't have the sufficient amount of planes that we need to go on these routes, right? So less routes, less revenue, less profit, okay? Or we take out some routes that we traditionally have that are not maybe high occupancy, and we divert those resources to our more busier routes and see if we can get some buildup of volume in the activity in that particular route, right? But that's hard to do unless you have some kind of special, right? If your San Diego to Arizona or Phoenix route is a moneymaker, right? Is it behind, time when we're to perform and put, so, Michael, is it off again?
Yes, you're frozen.
Okay, come in, do the same old, like, I like something new, right? I like something, and they just get, start taking shortcuts, right? They're no longer following what they're supposed to be doing, the procedures, because they know it so well, like, okay, if I can cut 10 seconds here, I can cut time here, I don't need to do that, that's nonsense. I'm gonna do it, let me do this over here, right? The problem is that if it turn out, then you have to go back to the process and say, hey, okay, where along the process you think it messed up? Like, well, I didn't do all 10 steps. I only did 8 steps. Well, why didn't you do all 10 steps? Well, this step 9 is like, it's not really necessary. Like, yeah, okay, now we see that it's necessary. Okay, so you probably want to keep it 1 through 10 and not try to, tailor it or custom do it your own way. Okay? All right. So that's that. Any questions on that one? Language. It's the. Alright, let's get this. It's just gonna stay steady for once.
There it is.
Yeah, it's nothing I can do about it, Mike, because the internet just unstable here. So it keeps dropping. So if we disappear, I
I can see
apologize.
it now.
Yeah, no, I know right now it's fine, but I don't know how long it's gonna hold. But let me know. Okay, so. Lean, okay? Everybody familiar with lean? Lean Six Sigma, right? Yellow belt, green belt, black belt, all that. No? Yeah, okay. So for those that are not familiar with lean is basically a process improvement system. Okay? So what happens is we look for inefficiency within a system, and there's a certain approach to it, right? And so lean came from Toyota, right? Toyota production system, in which because of World War II, right? Very familiar with World War II, Japan, Germany, Italy, right? They lost the access, right? They lost the war, right? And when Japan lost, World War II, United States occupied Japan, right? And for those that are familiar with the war, if you lose a war, guess what? You have to pay reparations. Okay? You have to pay the winning country the money they pretty much spent on the war. And it's not cheap. Okay, it's very, very expensive. It's basically how the United States ends up having embassies in different places. Okay, because you don't have the money to pay us, so we're gonna occupy some territory now. Okay, that's how the United States ends up in a lot of places, and that's how we end up in Japan. All right, so after the war, Japan had limited resources. The country was totally devastated by the war. They lost, so they had to pay reparations. The United States, said, fine, you know what? We understand, we get it. And it's not just the United States, it's every country that was involved in the war, they had to pay reparations to. That means France, England, Russia, right? All the people that were in the alliance, right? In what you call it, the Allied forces, okay? And so Japan was limited on resources and what they could do, right? And so within the factories of production of things, they came up with this system, specifically at Toyota, right? So before Toyota was making cars, anybody know what Toyota started off as? No? Toyota was in the looming business. Anybody familiar with looming? All right, so looming is a kind of an old term or old process, but they still do it now. But basically, weaving clothes, weaving thread. That's what they lose. Okay, you might see in like some old movies where you see long boards and they have the thread around this kind of structure, and it's moving, it's weaving all the stuff, it's making fabric basically. That's what Toyota started off as a looming, and then one day the owner of Toyota, Toyota, Toyado, that's how you spell it. He came to the United States to look for new business. And when he came to the United States, it just so happened to be the time when Henry Ford had just made the Model T, the car. And he saw the car and was like, oh my goodness, like this is the best invention ever. I'm gonna bring this to Japan and we're gonna do it the best, right? And so he switched everything from looming, they got out of that business and went straight into car making. Okay, so that's how Toyota started, right? And so following the war, they were limited on resources and were like, hey, okay, we need to figure out a way in which to be efficient, right? Because we don't have access to a lot of things, right? And so this is where lean came from, right? The tendency to be the characteristics of lean, right? And so they also call it just-in-time manufacturing, which you will see a lot of in accounting, right? Just in time, all right? And so just in time it can be applied a couple different ways, but basically the gist is that the product arrives at the time when it's supposed to, when it's necessary, right? Usually off a command, customer signal, a demand signal, okay? Nothing happens until and unless there's a demand signal. So basically, somebody walks in the door, they want a pizza, that's when we start making the pizza. Okay, we don't do it any other time, right? When you go to a restaurant, sometimes it says, they'll say, hey, this is gonna take a little bit longer to make, right? Because they don't have it prepped in the back, right? It's made for order, right? Like sometimes desserts are like that. Would you like this dessert tonight? It's our special, yes. Okay, well, please let us know now or let us know between, like in the middle of your meal, because it takes a certain amount of time to make it, right? It's just in time. We're gonna deliver it when you want it, right? When you ask for it, right? Not before, we don't have it stored somewhere, right? And so what that does is it makes sure that you don't have any excess inventory, right? Imagine they just start making desserts back there. They got 10, 15 of them just sitting there. You really don't know who's gonna buy them, right? And because of the nature of desserts or the resources, the material that it takes to make the thing, you basically have to sell it or get rid of it. Okay, there's no keeping it. There's no freezing. It's not like meat where you can freeze meat, in perpetuity, whatever, right? And so if I'm making a dessert that cost me $5 to make and I'm not selling it, guess what? That's $5 down the drain that I just lost. Or maybe on 10, 15. And one that is within some what we call initial culture. Another culture works a different way, okay? So have a lot of operations management aspects to it, a lot of, personal stories. Michael Keaton is in it. I don't know if you guys are familiar with Michael Keaton. And then the guy who just won, anybody ever seen the movie Everything, Everywhere, All at Once? Yes?
Hot dog fingers?
Yes, hot dog fingers, yes. The man, the guy is in there, he had the glasses. I don't remember his name, his character, but he's in that movie. But he used to be in the Goonies. Maybe you guys probably never seen the Goonies.
As a little kid?
Yeah, as a little
When he was
kid.
the inventor as a little.
Yeah, he has all the gadgets and everything. You guys probably never seen Goonies before. I don't know, maybe. Goonies,
Yeah, Goonies.
right? He's the little Asian kid, right? Who's
Yeah,
in,
he's the husband in.
right, yeah, he's the
Oh,
husband,
okay,
yeah,
I can
yeah.
imagine. Yeah.
Mhm. Yeah, he's the husband. He just won the award, right? Or won the award, yes, of that movie, right? He's in this movie. Okay, so either way, it's a good movie, but it kind of gives you an idea of, when this particular mindset came to the US, how it was accepted and how it contrasted to how the United States did their business in that. Is it gone again? Is it still sharing?
Nope.
All right, let's see what I can do here. Yes? Is it back on, Michael?
Yes.
Yeah, keep knocking this out. All right. Either way, all right. So, okay. All right. So, lean, it's a whole certification process in itself. And like I said, there's different levels. It's like karate with the belts. Okay, you got your white belt, you got your yellow belt, you got your brown belt, your green, your purple, and then your black, I think.
Orange.
orange or orange and black, yeah, I don't know exactly, but it has all those levels, okay? And each level, it's a little more complex, right? It speaks to the complexity, you're understanding the whole process and not just a component of lean, right? You understand the whole thing. You can be a lean, black belt. So you're running all these projects, okay? And so the first concept is Muda, right? Where we reduce waste, okay? Then we have Gemba, right? Which is identify, study, and improve the value stream. Then we have Top Time, ensure simple, smooth, error-free flow, which is determined, right? So we're looking, at, we got the problem, right? This is the issue at hand. We are observing, we're looking at to see, what the problem, what it looks like, right? Here we're determining or making a decision as to whether or not we want to do something or what needs to be done, right? We look at, the use, right? How is it gonna be implemented, that kind of thing. And then we hold, or we are looking for status quo, right? Where we make it normal, right? It's the new norm, right? This is more kind of like, this is all kind of change management stuff, right? So when we're looking at the new normal, hold the Kaizen, right? Kaizen is basically continuous improvement. And that's what they usually really push at Toyota, right? We learn all this stuff, but Kaizen at the end of the day is really what it's about, continuous improvement. Always looking for a way to improve the system, right? And they do it in every aspect. It's just not a matter of, processing. They think about the people, they think about the equipment, they think about time and space, right? They think about motion, right? It's kind of like feng shui meets, production sort of, okay? I'm not gonna belabor too much. I just want you to understand that this is part of the operations management. These are things that, companies really invest heavily in, and that they want people that are qualified in to do it. This, if you're certified, this easily adds an extra $50,000-$60,000 on your paycheck if you're lean certified. If you're a black belt, easily, right? Because it takes about a year and some change to get to black belt if you are consistent, right? But if you're not consistent, it could take longer. But a lot of companies, I know, for us in the military, we have a lean program, right? Waste processing abuse, fraud and abuse program. And if you come up with an idea or you take on one of the lean projects and you show that you created some efficiencies and some increase in productivity and everything, they will give you the difference, the difference in cost between what they were spending and the money you saved. You get that. That's the incentive, yeah. So I've seen people get $75,000 checks. Yes, I don't know how they pull that one off, but they do it, right? It doesn't matter, whoever it is, they get paid, right? Because usually those issues are on the installation level or on the department level, right? They're coming from DOD, or they're specific to the base, or that particular, that particular entity and what they do, like, Naval Air Station North Island, right? They have specific problems that are inherent to North Island because of what they do, right? They have jets, there are some carriers over there. They don't have carriers everywhere. There's not jets everywhere, right? So they have specific problems that they're looking at, right? If you can help solve those problems, right, by making the process more efficient, then they will give you that difference in money, right?
That's because that product is like large numbers.
Yeah,
right?
it's huge numbers, yeah. It's humongous, right? And I remember we had a team of folks. We had one team, they were working on some project, I'm not really sure what it was. And they got $900,000.
Not like ordering too many TVs for Buffalo.
No, yes, yeah, no. I wish your daddy, okay?
900 grand.
900 grand. Yep, they split it amongst each other. Came, still working. Just came to work. Noble, get your check. Here you go. Right. And so at one point there was a lot of clamor for these projects, but not everybody got to get on because they take the one thing I can say is that the lean process, it takes a lot of statistics, right, and understanding operations and operation management. And so most people don't have that talent, that knowledge base, right? So it was really a very steep learning curve in understanding you know, production, especially production management. Production management is a lot of statistics. And so understanding that, and calculus too, for that matter, right? But at the end of the day, these are some forms of waste that they identify, right? Overproduction, waiting time, unnecessary transportation, excess processing, too much inventory, unnecessary motion, and defects, right? And so they worked around these particular forms of waste and figured out, okay, how can we improve on each one of these particular areas, okay? All right, so, value stream mapping, so, let me go to the next, that's easier to do it this way, okay? So basically what they looked at is, okay, when they're mapping it out, again, they're putting all the details in from, this is an example from a hospital, right, doctor visit. Patient in, patient out. What happened between, you know, the patient checking in and when the patient checks out? What are all the time intervals? What are the activities that happen, to include the activities that the patient is enduring, right? We're talking about internal visit, internal functions and external functions, right? Internal to the clinic or to the doctor, you know, there's certain things happening in the background, right? The admin processing. Maybe we need to, you know, put in a thing for labs, right? Maybe we need to set up an MRI. Those are things that are not necessarily privy to the client or to the patient. Patient just knows, hey, go down here to X-ray or radiology and get whatever test the doctor ordered, right? But behind the scenes, there's stuff going on. And so this basically outlines or maps every activity, the time that it's gonna take, and basically what area it's affecting, okay? And you kind of see the information flow, right, and how it goes. And you can really identify really some of the places where you are expecting to see some delays or to see some gaps or some areas that you can probably improve, right? Again, Christina and I were just talking about, you know, doctor visits, right, or dentist visits, whatever, right? And so, you know, whatever was going on in the clinic or that hospital that the day, right, caused that to the doctor to have more patients that they normally would have, right? So their capacity was limited, and so that means their throughput was gonna be limited, right? But at the end of the day, when we look at the mapping, right, we won't see that. But internally, right, there has to be some function, there has to be something there that says, look, you know, another arrow that says, oh, doctor calls in sick. What happens then? Right? You gotta have something. You just can't say, oh, we're gonna just give it to somebody else, right? It doesn't work that way. If you only have one other doctor or two other doctors and they're booked out all day, right? There has to be some other mechanism. And so that's a place you can improve upon the process, right? To say, okay, in the event of, because that happens, right? People get sick, people can't come to work, accident, like, you know, the show shouldn't stop because you don't show up. Okay? You get hit by a bus today, I'm sorry, but things must continue, right? People still getting sick, people still dying, people, you know, things are happening. We still need to continue on, right? And so this really helps to map everything out. You can see it very clearly, and you can see, you know, all the time hacks and at the end of the summary, right? 120 minutes of wait time, 40 minutes of processing time, 160 minutes total throughput time, okay? So it takes 160 minutes from the time the patient comes in to the time the patient goes out, right? Whatever happens in between there, X-rays, pharmacy, that kind of thing, right? So 160 minutes is what, 2 hours and what, 40 minutes? Yeah, 2 hours and 40 minutes. That's about average for a ER visit, I think, right? 2.5, yeah. Yeah, ER visit about 2.5, right? If you go to a regular doctor's appointment, this should not take 2.5 hours. Something's wrong. Okay, something's very, very wrong, right? I've actually sat in the pharmacy on base for 2.5 hours waiting for my medication, okay? Because their processes are a little different, right? And they kind of, their capacity is limited, right? And their throughput's limited, but they're also doing, there's a lot of things that they gotta check off, and I don't know what goes on in the pharmacy, to tell you the truth. Like, I'm always astonished at how long it takes to get drugs for no reason, right? Walgreens does it in 10 minutes or 30 minutes, Why does it take 2 hours?
It's DRG wide,
Yeah, it's crazy.
every clinic,
Yeah, every clinic like that. It's nuts.
whatever process that slows them down is implemented everywhere.
Yeah, it's just nuts. So, you know, so this is pretty well mapped out, but for someone that's trying to redesign the process, this is great because now I can kind of see, you know, on a normal basis for normal situations, right? What is the amount of time that a patient can expect to come in and out? This is good for setting expectations for the patient, right? Because nothing worse for the patient than coming in. First, I'm in pain, more than likely, right? Secondly, and you know, you said it's gonna be 30 minutes, you know, if it's 2 hours and 30 minutes, I'm gonna be upset, right? And so if you tell me it's gonna be 2.5 hours, then I have some realistic expectation. Okay, I'll bring a book, I'll bring some work, I'll do something, you know, I'll figure it out. Also, you get to understand that within all this, right? What's missing out of all this, right? You got the patient, you got the wait time, you got all this stuff, right? But if you're looking at this, what's missing out of this particular process flow? What's missing out of this mapping that they're not accounting for? Hmm?
Don't laugh, I can't see it, sorry, don't laugh.
You can't see it?
Too small.
It's too small?
Yeah, it's pretty small.
You guys can see it? They're making it bigger right now. Let me see. No, you know, I'm not
What
gonna
does
try.
it say? What does it say in the purple square?
Okay, so the purple squares say check-in, visit prep, visit doctor, pharmacy, blood test. And then down here, is time hacks for each one for the patient, right? 15 minutes, check in, you wait, you wait 15 minutes before you prior to check in, 5 minutes to check in, 40-minute wait, then the visit prep is 8 minutes, and the wait is another 20 minutes, and the doctor visit itself is 16, the wait is 45, pharmacy's 11, right, and total is 120 minutes, total wait time, 40 minutes processing time, 160 minutes total throughput time. So they're counting basically what's going on inside the clinic or the, you know, the office, and they're accounting for the patient. You know, but there's something that's missing here that they didn't count for. And I'm like, why would you not? You need to account for that.
Share availability, room availability. Is that
Um,
right? Enough staff?
Yeah, kind of, sort of, right? Yeah, they're not counting for that, but
Maybe
you know.
when there's room for them to see them.
yeah, I'm assuming that that's why the waits are so long, because they're basically trying to get a room, right? So if you look at it, the office itself, the system is accounted for, right? The patient itself is accounted for. What's not accounted for?
You know.
The personnel, right? There's nowhere in here where the personnel in this 160 minutes is going to the bathroom, is stopping for lunch, is answering phone calls, is doing all this other stuff that has nothing to do with any of this, right? So they've accounted for the patient, they've accounted for the internal functioning or the things that go on the visit, but they haven't accounted really for the personal time that, oh, you know what? That nurse may have to take a phone call, right? Or how much time does it take for me to, you know, patient calls, it's not like the phone call stopped. I know you have the receptionist and all that, but the receptionist on the phone with the patient, and some other patient pulls up in front of them and says, hey, I'm here for an appointment, give me a minute, right? And they wait till that person is done with whoever's on the phone, then they check them in, right? But then what if that poor receptionist, she's like, I gotta use the bathroom, right? She's gone 5 minutes, hopefully, right? Tops, maybe 10, I don't know, right? Everything stops, right? Nobody else is getting checked in, right? So I really don't know how that's affecting the flow of things, okay? So they didn't account for that here. Not in an obvious way to me, right? Maybe they tucked it into these different time hacks, but as far as I can see, they didn't account for that time. And that's a mistake because that time alone is probably a good 30, 40 minutes at least, right? Depending on how big your staff is. Because you have to give people lunch, right? What happens then? They gotta eat. Doctors, I don't want a shaky doctor seeing me, right? If I walk in, doctors like, because they haven't eaten, then that makes me nervous. Okay? So you have to account for that time. So again, this is just an example. And if you were to do it, I'm sure it'd be a little more precise. Okay? All right. So when we look at, some of the things that happen, right? And this is specifically to a production line, right? So one of the things that in lean is that inventory hides problems, right? The more inventory you have, the more problems you can kind of tuck away, right? Because the more inventory you have, the more likely the array of issues you could have with each one, okay? And they're harder to identify, right? Just because you got 100 pieces in here, right? And you notice a defect possibly in a few of them, you don't know which one has the defect, and you don't know what kind of defect it has, right? You just know that you have a bunch of inventory, right? That is presumably ready for sale. Okay? So it gives you that misconception that you're ready to go, that you have a bunch of workable stuff. But what if you pull one of these pieces of this product and you get to a customer and the customer is like, this doesn't look right. Like, what's wrong with it? You go, oh, this one's not good. Okay, let me take it back. And you put it to the side. And you go back, you pull another piece of equipment or product, whatever it is, right? That one's fine, but you just wasted time, first thing. Secondly, now you have a piece of equipment that you can't sell, that you have to send back through the process to gotta get fixed, if it can be fixed, right? So you want to keep your inventory as low as possible, right? Or the water level as far as they say, right? And so, the more inventory you have, the easier it is to hide these problems, right? Low inventory exposes this problem because now if I have a low inventory, right, I already have a few things in my inventory to look at. I can identify, why everybody always come to this class? Like you've been here, is it 3 weeks now? That makes no sense. Okay, either way. So, the less inventory, the easier it is for me to identify problems because it's not as many in the inventory, right? And so if I have 20 particular items in inventory, I can probably peg it down to what's wrong pretty quickly. If I pull something out and it's not exactly up to, quality control standards, I can pretty much go, okay, got it, and just kind of move it and get something else, and then identify very easily if I have a batch of bad stuff, okay? So you're trying to keep the inventory low, and then, once everything is good to go, you want to keep your inventory basically low, right? If having inventory on hand is not something that companies want, okay? Inventory costs money to warehouse, it costs money to secure it, okay? And it's basically money that's just sitting there and doing nothing, okay? And so the smallest amount of inventory you can have, the better, all right? But you want to have enough inventory to be responsive to the demand signal. So there's the fine balance of forecasting, of understanding, okay, how do I get the right amount, right? Or at least the amount that I can hold me over till I'm done producing more to backfill the inventory, right? As it starts to empty out, right? But this is where the system comes in, where it says, look, I'm only going to start producing when I get a signal, okay? I'm not gonna produce I'm not gonna do continuous process, but I'm just producing stuff 24/7, 7 days a week. We're not doing that, right? We're doing it based on, customer comes in, or I get a request, hey, I need, a special design, special coat, special dress or whatever. Okay, no problem, it's gonna take 2 weeks. Okay, good to go, right? That's when I start the problem, that process. That's when I go source the material and supplies, right? And then I build it, knowing that I have a customer or client that this particular resource, this particular product, all the materials I'm using, and my time is allocated to, okay? And so I peg this particular project or job to that customer and that line item and that cost, right? So I cost everything out, to that particular person, right? And that's why sometimes even you make a product with for someone, and it doesn't work out, right? It's just like, okay, there's a few things you need to fix. Okay, we'll fix them, but they still need to pay, right? Because I made this based off the fact that you wanted it, right? Yes, we'll fix the discrepancies, but at the end of the day, you need to pay because guess what? I'm out of $50,000 because you put that request in, right? It just wasn't sitting around, right? It's different when it's just sitting around. It's totally another story, okay? All right, so we kind of talked about push and pull, last week, right? But at the end of the day, most of, the process within lean, right? Again, it says no upstream process authorized to produce until customer pulls, thus minimizing inventory in the system, right? So we only pull, right, when we have to, okay? We only pull when the customer puts the signal out there like, hey, I want this product, right? We push, right, but we push into the inventory. We don't push out to the customer, but we only push again once the demand signal comes from the pull, then we know, okay, we need to push into the inventory, right? Because now we've lost one. So that means we have a signal to make another, right? To stay consistent as to how many we have, right? Everybody ever been to the donut shop on B Street? All right, okay. When do they close? When did that donut shop close? You not familiar with what time they close? That's because they don't have a time. When did they close?
When they finish done.
When they run out of donuts. They make a finite amount of donuts, right? And usually by 11, 12, they're pretty much down to bare bones, right? 2 o'clock, doors are shut. No more donuts. Things are done, right? You can get some other cheap, stuff, but for the most part, they have a certain amount of inventory that they keep, right? And each day is different. Because they realize that, okay, on Mondays, probably gonna have a lot of people in here. Because it's Monday. As the week goes on, right? What am I relying on specifically for the San Diego market? What am I relying on for my customer base during the week? Like on a Tuesday, Wednesday, Wednesday, Thursday, Friday, even a Saturday, Sunday. Who am I relying on as my customer base? Specific to San Diego. Anytime.
Younger working population.
Younger working population. Okay, what time is relevant? So let's just say in the morning it's younger working population, right? But once that group is gone, who am I relying on then at that point?
I wanna say usually moms.
Moms?
One day students, their whole day kids school.
Maybe, yeah, students, yeah, right? San Diego specifically, we're talking about
Tourists?
tourists, right? Retirees
Used to be,
too.
not anymore.
Huh?
It used to be.
Yes, it's not, it's definitely declined a whole lot, but the donut shop doesn't seem to be affected. They seem to be just fine, right? Because because they gotten popular nationally. So people, they come to San Diego, they're like, I want to go to donut shop, right? Because they saw them on TV or something like that, right? So they don't have that problem of, not having inventory to sit around. They inventory goes pretty quick, right? But again, they practice some form of lean because demand signal that prompts them to make the inventory is really about the customer pulling, right? How many customers do we expect to pull to come to the store today, right? And that's based on just forecasting, right? During the winter, it's probably not as much, okay? Maybe it is, I don't know, right? During spring break, when the kids are out of school, that's probably not as much because parents are not necessarily out and about early in the morning, right? The summertime is different, right? So it depends. All right. Okay, so key point here for this part is that quality is essential input into lean system. The lean system is very much about quality over anything else, okay? But we have to do it in a way in which it makes sense and that we can get the best out and most out of our products, okay? Defects are waste, all right? So keep that in mind. Defects are waste, all right? So if something is defective, they've already chalked it up to saying, look, it's defective, it's costing us this much amount of money, we wasted money. Because all we're gonna do now is put this back in the system and refurbish it or fix it the way it's supposed to be, right? So we're doing the process twice. So basically, this way, no inventory to cover mistakes, we just talked about that. System designed to expose errors, right? Correct them at their source, not repeat in the future. One thing about, lean is that they like to solve problems at the point of the problem, okay? Some companies, there's a problem, you gotta tell your boss gotta tell their boss, and then they can do something about it. Not in lean. When you have a lean problem or issue in the lean system, you try to fix it right then and there on your own, okay? What do I need to do to rectify? Who better than you to fix the problem? If this is what you do every day, right? You know the ins and outs. Why can't you fix the problem, right? And if you can't fix the problem, you need to tell me what you need in order to fix the problem, right? What resources do you need to correct the issue, right? And so that's a big component in lean. And continuous product improvement in the system. Okay. Containers. All right, so, like I said, I wasn't going too deep into the lean. The lean, basically, you can go, like I said, you can go a year-long course on lean, all right? When I worked for Toyota, I think it was 3 weeks of lean. All right, very interesting, super cool stuff, especially when you see it in action. And if you can see it actually implemented in an organization like Toyota, it really is an amazing thing to where the way they set everything up. So basically, the way you see this set up here, they. Oh, this is better, right? So basically, everything that the person needs is right there for them. Okay, so even to this point where, let's just say, for instance, when I went to go see the manufacturing plant, the person or the people that were in charge of put the tires on the car, all right? So normally in other manufacturing plants I've seen, automotive plants, the tires and, the big components are like somewhere else, right? And you kind of have to call or you put in, hey, I need, a certain amount of tires, this many cars coming through the line, right? Toyota did totally different. Toyota basically, whoever the person was that was in charge of the tires, the car would come up and it's on an arm, right? Like I told you, it's a big robot arm, it's huge, and it's basically throwing the car like a rag doll, right? It puts the car down, person in front of it, and the tires and the wheels are literally right here, okay? And there's a little machine that they press, it punches out 4 tires, and then they just grab the car, and then boop, 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 and then somebody just like that, right? Didn't have to move, didn't have to go anywhere. That takes about a whole 5 minutes to put all 4 tires on, right? And so that is part of Kaizen and part of Lean because everything is there. All the components, all the parts of the materials you need is there. So that minimizes your movement, right? You don't need to go way over there. That could take you 5 minutes to walk, right? And 5 minutes to come back, okay? Oh, what if you got the wrong thing? Ah, guess what? There's no problems like that in Kaizen, in Lean, because guess what? All the tire options are there for the particular vehicles that are coming through that line, right? Because it's configured for certain vehicles, right? The way it works, they'll say, okay, we got to produce, 1,000 Camrys today, okay? So they reconfigure the line for Camrys, okay? And so We only have Camry tires here. For whatever model it is, because they're all the same tires. It's, you know, you get an upgraded, package, that's a custom order, so that's custom tires, and that gets done actually at the port. Which is another different thing altogether, okay? So the key to, you know, to lean is really having all the parts and equipment you need and minimizing the movement of the employee, the movement of the worker, right? Minimizing the movement of the supplies and the materials and having them right there at, you know, your, having access to them very easily. The only thing they don't have access to is really the control of the arm. You know, someone else is doing that, but that person is kind of overseeing the whole thing, the whole, cycle. The only thing they do have is they have a little button they can press to stop the whole system in case of emergencies. Okay? All right. Any questions? No? All right. Like I said, get your emails in with your groups by tonight. Tomorrow morning, if I don't see your groups designated, I will assign you myself and have those groups set up in a Moodle. Like I said, no more than 4 people per group, okay? And no less than 2. No less than 3, really. But if you want to do 2, I'm okay with it if need be, but 3 is really my minimum, okay? What else?
So as I said, like we are 2 right now.
Yeah.
But probably you will. give us an-
Yeah, I'll throw somebody else in there, but if I can keep you 2, I know you want 2, so if I can keep you 2, I'll keep you 2. Okay, alright, but if I need to throw somebody in, I'll throw them, okay?
Can you throw me your group that needs somebody?
Okay.
That work?
Yeah, yeah, it's fine. If I don't see your name in a group, I'm gonna throw you. Yeah, I don't even let you know. I'm just gonna throw you in a group. Okay. So tonight, send me an email. Let me know what groups you're in. And then after that, I'll get everything situated. Okay. Aside from that, make sure you get all your work done, and that's that. All right. Oh, title justification is due this week also. All right. The title justification, like I said, I just need to know the title. Why you chose the title, why you chose a particular topic. Okay, that's it. I don't need anything else. So don't make it, it should be a paragraph, most. Okay, at most, a paragraph. All right, the title of your paper, right, this is for your final paper. All right, it has to be based around operations management, some aspect of operations management, okay? Or production management. And like I said, just the title and why you chose this topic. Right? 1 paragraph. Don't go crazy. Right? Okay, I'll see you guys next week. Michael, Kang, I'm sorry, it kept dropping off. It's just the internet. But I'll see you guys next week, okay?
Okay, thank you, Professor.